Today in the Universe Sandbox simulator, I'm going to do something that has never happened in the real solar system. We'll send absolutely every object to the sun, planets, their moons, and even asteroids. Let's see what happens to them as they approach the star, how they'll start to break apart, melt, and crash into the sun. And most interestingly, will the sun itself change after such cosmic chaos? Let's start the experiment, and I'll tell you that I've added moons to all the planets in the solar system. They'll be part of this video, obviously. That's Earth's moon, the moon, Mars's moons, Phobos and Deimos, also many moons of Jupiter, Saturn, Uranus, Neptune, and the dwarf planet Pluto. Now in the sun's motion settings, I'll lock its position so that the sun stays in one place the whole time. And in the motion settings for the entire solar system, I'm completely resetting the velocity of all objects to 0. And by resetting the object's velocity, I'll ensure that all objects simply turn around and fly straight into the sun for a collision. And to start, let's see what happens to Jupiter's moons if we completely reset their velocity to 0. Well, as you can see right away, Jupiter's gravity pulled them in anyway. And here, as we see, Europa and Io have collided with Jupiter. And now Ganymede is approaching for a collision with Jupiter. Well, yeah, this option doesn't work for us because the goal of the experiment is for absolutely all objects in the solar system to fall specifically into the sun. And so, as we see, Ganymede is colliding with Jupiter, and Callisto is about to collide with Jupiter as well. I'll show you this process. Just a little bit left until the collision, and the collision happened, and such a large fire wave swept across Jupiter, so its 4 largest moons have just collided with it. And if we look at Earth, we see that its moon, the moon, is also flying toward a collision with Earth. And basically, the moon is falling on us into the Atlantic Ocean, and life on Earth will be destroyed even before being swallowed by the star, the sun. That's how it is, guys. Well, this doesn't work for us, as I told you. So, I'll do this simulation a bit differently. I'll turn off the gravity of all objects in the solar system so they can't attract each other. In this simulation, only the sun will be able to attract objects. To do this, I'll select all these objects and exclude the sun because nothing needs to be changed for the sun. I'll go here, go to the motion tab, and for all these objects, I'll disable the ability to attract other objects, but they'll still be attracted by the sun. And I'm also resetting the velocity of all these objects to 0. In this simulation, the planets will also have rings. Here, I've added Jupiter's rings, rings for Saturn, and rings for Uranus. Unfortunately, there are no rings for Neptune in the simulator. Also, for reference, I want to inform you that the mass of all objects in the solar system combined, excluding the sun, is only about 0.14% of the sun's mass. That is, there isn't even 1% of its mass here. Now you can imagine how much the sun outweighs all these objects combined. Starting the simulation, we see that Mercury has rushed toward the sun, as have Venus, Earth, and Mars. The moon is no longer going to crash into the Earth. The moon and Earth are now moving together toward the sun. And Jupiter's moons, as you can see, are also moving like this. Simply put, everything has turned toward the sun, and there are no more collisions with Jupiter, which is exactly what we need. And Jupiter's rings have just flown away from it. Wow, look, we see the same thing with Saturn. The rings flew off. Well, it's obvious why this is happening, because I've actually turned off their gravity. And while we were watching all that, Mercury has already managed to collide with the sun. Well, Mercury wasn't that interesting to watch, but Venus now. Venus is flying into the black zone. Let's see what's happening with Venus on its approach. The sun looks so big already from Venus's position. We can see that Venus is starting to lose its matter, and the average temperature hasn't really risen much yet. It hasn't had time to, apparently. And Venus will soon be swallowed by the sun. So the sun doesn't burn our eyes out, I'll switch to informative mode. This way it'll be comfortable for us to watch. And just like that, Venus is consumed by the sun. Next comes Earth. It's still far from the sun for now. If we turn on the habitable zone, Earth is just entering the red zone, roughly at Venus's orbit. There aren't any major changes on Earth yet. Not much time has passed, the temperature rose a bit, the average is 8 degrees Celsius, although the consequences on the planet are already visible. If we hide the atmosphere and clouds, we see how many regions in South America are flooded, and many lakes appeared in Africa too. It's possible that torrential rains have simply started on Earth. Well, yeah, because there's so much water vapor in the atmosphere now, and the atmosphere is starting to get saturated. And soon, it seems, Earth will be hit by a very strong greenhouse effect. And meanwhile, by speeding up time, Earth is already gradually approaching the black zone. I'll stop time right about here. We can see that the moon is lagging behind the Earth quite a bit. This is what Earth looks like. Everything seems fine on it for now, but it's moving at a huge speed, and it's increasing, already over 180 kilometers per second. The distance to the sun is shrinking, the temperature is 28 degrees Celsius, but this is the distance left to the star. If we look closely at the planet, there aren't many changes compared to our last observation. It even looks like there are fewer watery areas on Earth now. But I'm going to do this. I'll go down to the Earth's surface somewhere here and show you the star. There it is. And now from this spot, I'll I'll speed up time and we'll see how the sun approaches in the sky from Earth. This is how the process looks. The clouds are blocking the view a bit, but you can still see the sun getting closer. Look at that. It looks so epic, doesn't it? And now the sun will just block our entire view of the sky. I'll stop time. And now that Earth has come so close to the star, we see the oceans have suddenly started boiling away. Hiding the atmosphere and clouds, we see that yes, the surface is starting to dry up. 1 second per second is passing. Look at the temperature parameters. Earth is already starting to fly into the sun and the temperature on it is just enormous. And now it's going to completely disappear. And by the way, the Roche limit somehow doesn't work here. Earth doesn't have time to break apart. It goes straight into the star. Let's see how it goes with the gas giants. Next is the moon, which lagged behind the Earth back there. For now, the sun doesn't care at all. Now the moon flies in, the moon is swallowed, and there's no effect on the sun yet. Now let's see what happens to Mars. I'll speed up time even more. It's sort of in the green zone right now, and the temperature on it is slowly rising. But you see, because they're flying at such high speeds, these objects don't have enough time to heat up significantly. And here's Mars. Approaching the star, I'll pause time here. It's only reached a maximum temperature of -24°C, even though Mars is already 0.04 astronomical units from the star. That's very close. If we look at the surface of Mars, there are some changes. There are some icy or liquid patches here. It's not clear what they are. Phobos and Deimos, I assume, have fallen behind. Oh wait, look. Phobos is ahead, while Deimos is actually lagging behind Mars. And now Mars is about to crash into the sun. That's it. Mars has dissolved into the sun's plasma. Next, we'll have the asteroid belt flying into the sun. We can see Jupiter's rings scattering like this. Here are Saturn's rings scattering, and Uranus is over there. Let's see how objects from the main asteroid belt crash into the sun. By the way, not all of them crashed. Vesta has vanished, and Jupiter's rings have made it to the sun, but they actually survived. You see, asteroids are flying by, and they're simply being swallowed by the sun. And now Saturn's rings are reaching the sun. Wow, look at that. They're stretching out like this, it looks epic. Next up is Jupiter with its moons. Let's let everything get a bit closer. The outermost moons of Jupiter have already been swallowed up. I have paused time for just a moment. I will slow it down to a rate of just over 1 day per second, and we can watch as Jupiter's small moons on those distant orbits crash into the sun. And then we will wait for the moment when the most interesting moons finally approach. By the way, let's see exactly what's happening with Jupiter. This is how Jupiter looks. Everything's fine with it so far. The temperature is -155 degrees. It hasn't even really had time to heat up. And now it's getting very close to the sun. I'll slow down time. I believe Europa will be the first of its famous moons to collide. Here's Europa. -85 degrees, and it's heating up rapidly. Whoa, 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 what was that? I missed it, didn't I? I didn't manage to show you the actual collision. Oh well, at least we saw what the temperature was. Now, the next interesting moon that will collide with the sun is Io. And here's what's happening to it. It's losing matter. I don't see any kind of atmosphere on it. And there goes Io colliding with the star. And the next interesting object is approaching the sun. It's Jupiter. In the sun's stats, its mass and radius haven't changed at all yet. I see that Jupiter isn't even stretching from the sun's gravity. Perhaps it also doesn't have time due to its high speed. Well, the collision is about to happen now. The collision has started, and as we can see, our star has turned more blue. Now that's interesting. This is what the whole thing looks like. Even though Jupiter is the largest planet in the solar system, it's still very small compared to the sun. But Jupiter has fully entered the star, and only Jupiter was able to have some impact on the sun. Oh my goodness. The sun's surface temperature is over 75,000 degrees Celsius. Incredible. But the mass and radius are unchanged, and the sun's luminosity shows a 1% increase. And here we have the rest of Jupiter's moons that haven't crashed into the star yet. I'll speed up time a bit more. Amalthea crashes into the sun. And here come Ganymede and Callisto. Let's take a look at Ganymede, of course. The sun has changed its light, and now objects are lit differently than before. And so it stays close to the star. The simulator shows Ganymede is now moving at 568 kilometers per second, and its speed is still increasing. And Ganymede crashes into the star, just like that. And the last of the major moons left is Callisto. And now it's going to hit the star too. I'll pause the time. Here's Callisto near the sun. We see that nothing much is changing there either. And there Callisto is swallowed up. We can see a burst of matter from the sun because of it. Well, Jupiter's last moons are colliding with the sun, and that's it. The Jupiter system is destroyed. Only the rings remain. They're mixing with Saturn's rings, and next come Saturn's moons. Let them get a bit closer. This is how Saturn's moons are moving. I'm slowing down time more and more. Made it. Well, the outermost moons have already been swallowed. Iapetus will be the first of the large ones to fall into the sun. We'll take a closer look at how Titan behaves as it approaches the star. Titan is approaching now, slowing down time. Seriously, just about like this. And this is what Titan looks like. The maximum temperature in certain locations is already in excess of 60 degrees Celsius. If we hide the atmosphere and clouds, we can see its surface like this. And now Titan begins to be swallowed by its host star. It looks epic, of course, but also very terrifying at the same time. Oh boy, that's it. Titan has been destroyed. Next, as we can see, Saturn's moon Dione is flying in. Dione collide. Enceladus' turn. Enceladus has collided. Pandora and more of Saturn's small moons, and Saturn itself is starting to approach. Let's take a closer look at this process, of course. This is what Saturn looks like now. It's lost its rings, of course. And its collision with the Sun is about to happen. I wonder if this collision will change the Sun in any other way. And there, Saturn crashes into the star. Here are its stats. Mass, radius, and luminosity are completely unchanged. Only the surface temperature changed to over 36,000 degrees Celsius. So the collision just heats up the star and nothing more. Now we see the rest of Saturn's moons colliding. Here they are approaching and crashing into the star. I'll speed up time to see how the remaining moons of Saturn gradually collide with the Sun. Next is Uranus with its moons, but two more objects are moving, Chiron and another one. That other one has collided, and now Chiron is going to collide. I'll speed up time so Uranus reaches the Sun faster. Okay, we see Umbriel, Ariel, Uranus's moons are hitting the Sun, and now Uranus itself will approach. Moon Miranda is flying in, and you can see Uranus itself, I think. Here's Uranus flying along. Let's check its temperature. By the way, it's heated up quite a bit. Positive temperatures everywhere, with an average of 132 degrees. Uranus itself looks like this. Let's watch Uranus as it enters the star, a dark spot on the Sun's disk, and now it is finally gone. And here are the last of Uranus's moons hitting the star. I take it Neptune will be next in line now. Its distant moons are colliding with the star. This is what Neptune looks like near the Sun, just like this. But the temperature here didn't have time to heat up as fast, unlike Uranus. There are negative temperature values everywhere here. And this is how the Sun completely swallows Neptune. And we see a plasma burst like that, as if something happened. And the rest of Neptune's moons are colliding with the star. That's clear enough. Next, objects from the Kuiper belt will start moving, and the closest one is Pluto. And the Moon Hydra will collide first, then Charon flies in, now Kerberos, and Pluto itself. And this is how Pluto looks. It's losing its matter. As we see, there's a tail, but the temperature is negative everywhere, even on the sunniest side. And I suggest we take an epic look at this collision this time. Let's descend somewhere to Pluto's pole and turn the camera toward the Sun. And I'll speed up time and show you the process of how Pluto will be swallowed by the star. Here we are getting closer and closer. The Sun in the sky is bigger and bigger, and there's just a tiny bit left. I don't know where this collision will start. Let me slow down time a bit right here. Let's look around. Well, it's like we've already started colliding. Or is it just me? I don't know. Well, now we've definitely for sure started colliding. Everything's covered like this, and it's like we're inside the star. Looks like I'm inside the star, and the simulator displays it all like this. But in the meantime, let's see how the Sun will swallow the Kuiper belt. All the objects are flying toward it. Sedna, Gong, Eris are colliding with the Sun. And object 2018, VG18, is the last one left. It's about to collide too. That's it. Absolutely all objects in the solar system have collided with the Sun. Now it's time to see what happened to our Sun after all these collisions. 1 month passes per second. We see that the temperature has stabilized. It's 5,512 degrees Celsius. Mass and radius are completely unchanged, and luminosity is only 1% higher than before. So roughly speaking, the Sun didn't care at all about all these collisions. Now I'll turn on the normal mode. Let's see what the Sun looks like this way. Well, basically, just like it usually looked. So this is the result. The Sun was tickled, to say the least, and that's it. If you liked the video, give it a like and write a comment. Thank you very much.